This video was supposed to be very different from what you're about to watch. I have been planning this video for many months now. I've been working on a ton of different projects, been building out River, R8Y, PickThing 2.0. All these big projects I've been working on have been using Neverthrow, not Effect. If you're not familiar with what either of these are, Neverthrow is basically a way to get better error handling in TypeScript. So instead of having try catch hell for everything you're trying to do to make your software actually kind of durable and not just explode at the slightest sign of an error, you can use Neverthrow to make that whole process a lot easier. And I've been really enjoying that library. And then there's Effect. Effect is not a library, Effect is a language. It's a completely new and different way of thinking about your TypeScript projects and how to build them. It gives you all the stuff that Neverthrow gives you of like good type-safe error handling, plus 10.5 trillion extra things on top of it. It is an insane monstrosity that is absurdly powerful, and it's really good. I kind of got into it at the start of the summer. I made that video with Ethan, like kind of figuring out how Effect actually works. I was really enjoying it at the time, but I kind of just fell off of it. I found that it wasn't providing enough value for me in my day-to-day to really be worth the extra mental overhead and verbosity that just comes with writing Effect code. So I moved off of it. But before I did it, I wanted to be like honest and fair with this. So I went and I gave Effect another shot. I wanted to look at it with fresh eyes and throw it at like some of the hardest problems I've been working on right now, specifically in the River project. It's basically an open source project where I'm building a TRPC-like experience for AI agent streams that are fully resumable, fully durable, fully type safe front to back, all that stuff wrapped into one. It's a very tricky problem, and I wanted to see if Effect would work for this. So I went and I tried it. And this was the end result. The first thing I got out of it was a crash out on Twitter. And one of the first things I wanted to see if it could do was take an Effect stream and turn it into a readable stream that I can return from an endpoint. And that is nowhere to be found in the documentation. I spent like 5 minutes searching for this. I checked this like 6 times. I wanted to be very certain that I wasn't just being a moron before I posted about this. But I could not find any references on the documentation to stream.toReadable stream, which is all it is. That's the entire method that I was looking for. And the only way I actually ended up finding it was by asking Claude. I opened up T3 chat and I'm like, hey, is this possible to do with Effect? It's like, yeah, of course, you can just do this. Just pipe your stream into the toReadable stream and it works. And I'm like, cool. Where the hell is that in the documentation? What the hell are we doing? And I had this long post and crash out. I won't read it here. You can go see it on my Twitter if you want to see that. I'll have a link down below. And then on that post, Michael, one of the guys behind Effect, replied with this. I won't go through the whole thing. The important piece here is I feel like the best docs come out of Claude with proper context. Add the Effect repo as a Git subtree, ask Claude and tell it to write tests to ensure the behavior is what you expect, and it will work incredibly well. I was very annoyed at this point because the whole thing was just, it was way more annoying to figure out how to do these basic things than I would have liked it to be. So I was pissed. I was like, you know what? Fuck it. We're going to go do this. And I went way harder on this than I probably should have, which is usually what ends up happening when I do these things. And this is what came out on the other side. I hacked together a custom agent in OpenCode, which is way less cool and complicated than it sounds. It is literally just a text file with a system prompt and then a bunch of repositories get cloned onto my computer. I didn't do anything special here, but I did set it up so I have this nice workflow where whenever I open up OpenCode, I can hit tab twice, I'll get my codebase docs agent, and now I can search through the Effect codebase, the Svelte codebase. I'm getting remarkably good LLM responses on how to actually use these technologies correctly. You'll see if I ask it this question, how do I convert a stream into a normal stream? And then how do I return this from a Svelte endpoint? Hit enter. It's going to, instead of just like spitting something out, it's going to start writing a bunch of commands. It's going to be grepping through the entire Svelte documentation and the entire raw Effect codebase. Because funny enough, if there isn't any good documentation for something like Effect, you know what is really good documentation? The test suite. The actual raw implementation of all the different features. If you want to figure out how something actually works, you can't just go look at how it's actually implemented. This isn't exactly feasible for me as an individual to go do for everything I'm working with. But when we have these models and agent harnesses, they actually make a ton of sense for this kind of thing. And then with this thing, we get these like actually good results out about how it works. In fact, this result is not what I expected it to be. I expected it to just give me the stream.toReadable stream thing that I wasn't able to find before, but then found later. And But apparently there is also a toReadable from Effect platform node that you can use to convert an Effect stream into a readable. And then we can go into a SvelteKit endpoint and we can just do this. I didn't know this existed. Apparently it did. It found it deep within the internal effect packages. And I'm like, okay, cool, let's go test this. I wrote out this basic example, just have an array of random things. We're mapping through all of them. We're putting a delay of 200 milliseconds in between them so you can like see the stream coming in. We are converting the stream to a readable and we're returning that as response. If I go into my HTTP client here, I hit run. Look at that. We have a fully functional stream coming from the node platform.to readable. And so then the next thing that happened is I posted about this. I was like, yeah, it does actually work really, really well. I also use this to do some testing in Svelteland. I promise this is not a Svelte video, but I think it's a really good example of how using this pattern can actually make the models write good code and stuff that it doesn't know super well. Because the models at baseline are actually pretty good at general effect stuff, but they're really, really bad at like some of the more niche and complex libraries. And they're really bad at figuring out how to fit all of these pieces together in a complex way. There was a lot of complex code that I ended up writing after this that the LLMs couldn't help with at all. And that was the next piece of this story. But I tested this with Svelte because I wanted to see if I was able to get an agent to create Svelte code with the new remote functions pattern that was introduced like less than 2 months ago. So very, very new stuff that is not in any set of training data at all. And the end result was really, really good. You can see here, this is like the open code session. I just made it public. I don't really care. The prompt was, I want to set up this project with a sign up page, give it a bunch of inputs, do some styling, all that stuff. But what was really cool about this is it used a sub agent here where it basically called the agent I created for parsing through the documentation and raw source code of these projects to get up-to-date information. It used it by doing some research on how to actually implement all these different things. It gave a bunch of examples on how to actually use remote functions. And this is all correct. It's being pulled right from the docs. You can tell because it's using Validbot in here. That is something that I don't do in my normal projects. I typically end up using like Zod or Effect Schema, but this is very much just being pulled directly from the documentation because the way these models work, I found, is all I really care about is how smart it is at baseline. That's really the thing that I'm looking for. I just want it to be able to pattern match really, really well, and they are awesome at that. If you give an example of like, hey, here's how I implemented X thing. I want you to implement Y. It's very similar to X. Use X as a reference, but go implement Y, and it's like something that's a different flavor. Like if you have a sign up page and then you wanted to implement the login page, there's gonna be a lot of overlap in how those two actually work. If you do one yourself or the way you like having it built, it'll do a really good job of referencing that implementation to make the other one, even if it doesn't know the underlying primitives you're using. If it's like custom stuff in your code base, or it's some more niche library like a Svelte or a Nuxt or something like that. And this was the final results. I know it just looks like a shadcn logging component. That's not the point. The point is that it actually works correctly and is using the new form Svelte action thing so that if I do like Ben Davis, com, and then we'll do this. And then if I try and create an account, I'm going to get an error that the passwords don't match because it's doing the correct validation based on the data that's sent to the server. It'll use the Validbot schema to validate this correctly. I can fix the password here, create the account, and then it works. All that was one-shotted directly by just giving the agent the things that it actually needs to understand how to use Svelte correctly. And that same exact principle works really, really well for Effect. He was not lying when he said that this is a very, very good way to use Effect. It absolutely is, and I've actually been getting a ton of mileage out of this. Kind of the way I've been thinking about and working with it lately is the docs are kind of like just a really good collection of a raw reference of like, hey, here's the general things that Effect can do. They have streams. You can get a good idea of like generally how streams work. But oftentimes in Effect world, you're going to find that you need to like implement something very weird and specific with streams. You need to get like a deeper understanding of exactly how these pieces fit together, or look for something that you can't quite find, or try and understand how these actually work. The raw code search works really, really well for this stuff. But we're not done, because I wanted to use the effect stuff for the durable streaming work I've been doing. The whole point of River is to make it so that I can have a durable agent stream with full stack type safety and a very clean and easy package. I have been through hell trying to figure out how to get the Redis implementation set up correctly with raw web streams, and a lot of the stuff I was seeing on the effect streams made me really feel like this would be a much better way to do things. And took a lot of effort, but ultimately I was able to get this working, where if I just ask it this question, where it's going to start running, get this in here, I can just hammer the refresh and it's just going to keep streaming in. It is all being durably stored in Redis, and then whenever I refresh this page with the resume key, it's going to pull the data out of Redis, subscribe to the pub sub connection if it's there, and then give me the correct data down in the stream in just a nice idempotent way. It's exactly what I wanted. It works super, super well. And this implementation is 100 times better than the crazy hacked together, never throw implementation that I had going beforehand for this project. I will absolutely be converting the core of River over from just like raw, never throw Zod TypeScript over to Effect, because this is going to make this project so much easier and more maintainable, because there are a lot of weird edge cases in these streams. Like if I'm doing a generation here and I refresh, I want to be stopping the stream that's currently happening on the server and then start a new one when it reconnects. I don't want to leak any streams and have any like dangling processes that will cause my server to slow down. I want to make sure that all that stuff is happening correctly. Getting that lifecycle right is very, very difficult to do outside of Effect, especially with the raw readable streams primitive. It's just not very good. But with Effect, the actual code for this becomes so much simpler and easier to reason about. I have this like run question asker agent function. I started off by just getting my AI SDK stream up here, generate an ID for it, create the special start and end chunks just so that I can like keep track on the Redis side of like when the stream is done. Because when the stream is done, I don't want to keep like subscribing and reading from nothing. I want to just abort and close everything at that point. So I have these two for keeping track of all that. I start the stream by just making a stream from the start chunk. I create my actual stream here by just concatenating the start chunk with the raw AI SDK stream. And then we go down here and we do the thing that took me way too long to figure out. In fact, I didn't actually figure this out at all myself. I was stuck on this for way too long. I spent a ton of time trying to figure this out. I went really deep. I implemented this like 5 different times trying to figure out how to do this, because the hard part about this problem is I have to take one stream and then I need to effectively split it. I need to have one stream getting sent down to the client that can get aborted and closed at any time. I need to just like set that and forget it. It's fine. And then I need to have another stream that's running in the background on the server that is durable, that is actually writing to Redis. Because if the client disconnects or does something like that, I still want the stream to be running so that we can resume it later. I have to split the stream to do this, and you're able to do that with the stream.broadcast. I figured that out really quickly. That was fine. And the problem there was with the scopes. I'm not going to go too deep into how all of this actually works. I don't want this to just be an Effect tutorial because that will take way too long. But effectively what I had to do here is I had to make a new scope, because normally these functions are scoped to their execution. So we return a readable stream from an effect. The generator for that readable stream will just keep running until we abort it, and then it'll just clean everything up. The thing is, I don't want that to happen. I don't want this broadcast to get terminated if that readable stream gets terminated. So I have to make a new scope. I have to extend the scope into this broadcast call here. And then I use the scope. I call Effect.forkin. I think the best analogy here is honestly threads. If you're familiar with like how threads work in like real programming languages, effectively it's just like another place to execute code. I create a new fiber here and I go down here, I pipe everything through, I take my background stream, I run through all of these, I append each item of the stream to Redis, and then I have this effect.ensuring. This code right here is the reason why I am completely effect pilled and will probably never go back to using literally anything else. This is so unbelievably helpful, it's insane. Effectively, what this is doing is it's just saying that no matter what ends up happening, this code will get executed. So when this finishes, when this stream is done, it's empty, we're ready to close it, the ensuring will call, and it's basically just a background cleanup thing. So in this cleanup, saying, hey, the background stream closed, I'm going to do redis.append to stream, append the end chunk, and then I'm going to close the scope, and then that's going to terminate that fiber, and then we're all done and we're all good. This is doubly useful in the subscribe to stream effect here. This is the one where I will read from the current Redis stream. I will get the existing messages that are already in there because I'm using a hybrid of the streams primitive within Redis and a pub/sub so that I'm writing all of the data to the actual Redis stream every single time. But I'm also writing that data to a pub/sub because I don't want to just be hammering the streams.read over and over and over again. That's going to make the server much slower and hammer the Redis instance in a way that I don't want to be doing. I want to just read the base data out of cold storage, and then the fresh entries can come from pub/sub by doing the subscribe. So I get my current ones. I go through here, I create my like on function so that every time we get a message, I will process that message if it's of the right stream key. And then I do the Redis client.subscribe, pass in the stream key. We now have our subscription. But then effect becomes really useful again, where I add this scope.add finalizer, pass in the scope, which I'm passing in as a parameter to this function. I'm defining the scope in the parent effect, which is basically the request that is sending down the readable stream that has all the Redis data within it that we're reading out of cold storage and out of the pub/sub. Whenever that is done, this finalizer, we will go through, we'll log we're unsubscribing from the stream, we will unsubscribe, and then we will quit. This will get cleaned up correctly every single time, no matter what happens. It is the best. This makes my life so much easier. Actually getting this logic right to make sure that I was cleaning everything up every time was so damn difficult when just doing it with like raw readable streams. And you can see in the app here, if I start a new generation, I go in here to the console logs, I'm going to refresh this. When I refresh it, that means that the resume scope is now open. And if I refresh this again, we're going to abort the getting stream because it was aborted on the client because we refreshed. The resume scope is closing. We are unsubscribing from the stream. The get stream is ending. And then we are opening a new scope because we're refreshing it again. And when this whole thing terminates, it will run all of this again, clean everything up. It makes my life so much easier. And then this whole Twitter saga ended with, they got me. I am fully effect pilled. Everything I just went over here, the insuring is amazing, the pipes are amazing, the whole ecosystem feels incredible. But there are like obvious caveats. I think that this reply from Michael on that post sums up my feelings about a lot of this stuff really well. And it's why I wanted to make this video right now, because if I try and make this in a week, it's just not going to work. Because the reality is, like, he is right. The only thing I was stuck on was 2 lines. I had all of that implementation figured out and working myself. The thing that I was missing was the understanding of the scope, and I literally just needed to add in that scope.make call, that scope.extend call, and that was it. That was the only thing that was really missing from my implementation. The thing is, it is just 2 lines of code. It is just like, oh, just do this. And that's a very common thing you'll hear from effect people in the effect world. We're like, it's so simple, it's so easy, it's just these 2 things. But the thing is, there is so much knowledge and understanding that goes behind those 2 lines of code. Those 2 lines of code have so much behind them. You are creating a scope and you need to understand what a scope is. And then you are using that scope to create a fiber. You need to understand what a fiber is. You need to get how the lifetimes of all these things actually fit together and work. You need to have a good understanding of the environment you're running this code in. You need to know how all of these crazy pieces fit together, how the effect pieces can be piped together in the right way. Yes, it is 2 lines of code, and yes, the end product is a shorter, simpler, quote unquote, piece of software, but there's a crazy learning curve that you have to go through here to actually learn effect. When people say you genuinely do have to break and change your brain in order to use effect the right way, I am fully bought in and I fully believe that it is the right way to go. I will talk about in a sec, like the things that effect has taught me, but like this is the right way to write software, and this feels like just a better version of TypeScript effectively. I love it. It's great. I do not want to use anything else at this point. The effect team is amazing. They built something extraordinary here, but there's a very real gap here between going from, oh, I didn't even know that JavaScript had a yield keyword, to all the crazy nonsense that I'm building here. And to be fair, the stuff that I was working on here is like library level code. This is much more complicated and difficult stuff that you would be doing in your normal day-to-day work. Adopting effect for like just normal CRUD logic and normal business logic is not this hard. It is much, much simpler and easier to go from await db.getUsers, you do your logic, to yield star effect.try promise db.getUsers. That is a much easier jump to make than going to the stuff I've been doing. But still, it illustrates the point really well that like what you are doing when you are learning effect is you are not learning a library, you are learning a language. And it's one of those things where bridging that gap from knowing nothing to being useful and competent in it, the skill floor is just so freaking high on effect. It's very, very hard to get into. There are much better ways to get into it at this point. I think, honestly, like the LLM thing, as hilarious and weird as this may seem, this like actually is a genuinely good way to figure out how to use effect code. Like just giving one of these coding agents access to the raw effect code base will get you really good results, and you can learn a lot going through this. I was able to use this to basically figure out everything I needed to do up to the scope problem, and the scope problem was one where like I had to sit down with the creator of effect in Theo's apartment and just hash this out for like 15 minutes. It was like, oh, that's how it works. Cool. And I realize that's like not a thing that everyone has access to, but also they have an awesome Discord. They have a very active community. There are tons of people who care a lot about this and will answer all of your questions. It's very doable if you really want to do it. And I do think it's worth doing. Because this is basically the second time that effect has completely changed the way I look at software. The first one was back in May, or ish. I don't know. Time doesn't really exist for me anymore. But whenever that was, at some point back then, I went through and made that video with Ethan Nizer, and my eyes were open to the fact that there are a lot of errors that happen in programs. There are a lot of ways that things can go horribly wrong and fail in weird and unexpected ways that are very, very hard to catch if you are not using errors as values. I've talked about this before, but one of the things that I was always really annoyed with Golang about was the if error not equal nil thing, where every single time you called something, you had to handle the error case in some way. Now, to be clear, I feel like the ergonomics in Golang world are god awful. I don't like them. I don't like how it feels to have to handle all of these errors. I feel like Effect does it in a much nicer way, where if there is an error that happens within one of your effects, it becomes a part of that effect's type. So this effect right here, the subscribe to stream, it'll return void, and then it will also have an error type of Redis error. And in the parent functions where I call this, like in this resume question asker agent function, I'm calling redis.subscribe to stream. It has this Redis error. Since I'm not handling that error in this function, it just automatically gets bubbled up to the parent caller of this effect. So this effect returns a stream, and it also has a type of Redis error coming from the subscribe to stream. And that just works all the way up the chain, all the way to the point where I hit the actual endpoint. And I made this little wrapper here where inside the get endpoint effect function, which is the thing that is actually running my endpoint here, I am piping it into this effect.catch tag. This catch tag will basically catch on any error you end up getting. And when I get a Redis error here, we're going to do effect.fail new endpoint error. So now this get endpoint effect has the endpoint error type on it. And then finally, in this endpoint wrapper I made to just make my life easier because it was getting verbose, I pass in the effect that has an endpoint error. We run the effect, and then we match the causes. If it's successful, we return the response. If it's a failure, we go through and parse it. If it's like just a named failure, like we created it, we'll return the actual error with the status code and the message. And if it's some random unhandled thing, like a server crash randomly, we return a 500 with an unknown error. You can obviously get way more granular with how you actually handle the errors here. It makes stuff like retrying way easier. It does so much to make your life easier. Handling errors as values is absolutely the right way to be going here. And then the way it rewired my brain this time is this right here. Be honest, some of you are better engineers than me, so you'll say yes to this question, but like how many times have you realistically, whenever you create like a Redis client or a DB client or whatever, how often do you correctly clean that up? How often are like dangling resources getting properly handled and the life cycle of your app is actually well put together and secured? How well are you cleaning up these resources? How durable is your actual thing? Is it just exploding out of nowhere and then, yeah, it is what it is? Like in this Redis service right here, whenever we close the Redis service, which means that's when like the Lambda terminates or the long running process terminates or whatever, we are going to take this main Redis client and we are going to actually quit it. Because we have this scope.add finalizer, which normally the scope stuff is not as complicated as I was saying in this video. It's generally speaking, you can just wrap an effect in scope.scoped. You will now have a scope within that effect. You can add a finalizer or an ensuring to it so that anytime this effect finishes, you run this cleanup. And this was really, really useful in some of the stuff I've been working on over the last like day or so, where I was taking that like open code agent thing that I made that I cloned on my computer. And I'm like, hey, what if I ran that in a sandbox? And I did. It works. It's hosted on Daytona, and it actually works surprisingly well. I'll show you that in a second. But in this code here, we're creating a sandbox, we're running it, doing a bunch of stuff with it. But the important piece is that if we are not running this in the background, if we're just running this as effectively a local server to just have a hosted instance with all the docs on it that we can just query back and forth with, I have this finalizer on here so that whenever we're done running this thing, we will just do effect.tryPromise sandbox delete. So I don't have any dangling sandboxes. I don't leave it open. I don't do anything like that. Once I'm done with the work, I will just delete it. And this will run no matter what. If something errors beforehand, it'll run this finalizer. If it gets interrupted, it'll run this finalizer. It just does all this stuff correctly. Because in my root index.ts file, I am running my program as a fiber. And then I have my fiber here. Whenever we hit an interrupt or we hit a sig term, I will go through and actually fiber.interrupt on my program fiber, which will trigger a real interrupt, which will allow Effect to go through and clean everything up before it terminates the program gracefully. And that is a magical thing to have access to and something that I've never really been doing before, which I will be doing going forward. And Effect makes this 10 trillion times easier than it would be to just do this in normal TS code. Because obviously in a lot of places, it's like, oh yeah, just at the end of the file, run the cleanup, who cares? Well, what happens if it errors before then? What happens if it breaks halfway through? What happens if it gets interrupted? All of these weird life cycle problems just melt away when you're working with Effect. That's why I was so hyped on it with the stream stuff, is because streams are just like that. These are long running things that can get interrupted and broken at any time. You need to gracefully handle these resources or else your server is just going to fall over and it's going to suck. There's some other weird kind of quirks with Effect that I've noticed having worked with it more over the last like week or so, where like one of the big ones is that there are like 10,000 different ways to solve every single problem, which is another reason why it's so damn difficult. It's also one of the reasons why documenting it is as difficult as it is. I do fully sympathize with the team in the problem of like trying to document this fully sucks. but also like a really good onboarding guide on like, hey, basically a language tutorial is what they need. And then they also need to just have a like raw full API reference somewhere. Like just, you can just AI generate that off of the like actual source code. Because if you hover over the type hints on a lot of the things in Effect, they're amazing type hints. Like they have really good examples in here. They have a good illustration on how pipe works. Like this is way more useful than the documentation is, all this stuff in here. Like if I just had a thing where I could go to a website and I could just fuzzy search through all of the effect components and then maybe have like something that would like fuzzy search what I'm looking for to the correct effect piece or whatever, and then just show me this, the raw type definition, and then all the things they have loaded inside of the actual package itself. This is awesome. This really does help a lot. But still, there are a billion ways to do things. When I was hanging with Michael on Friday, it was like I was initially doing this differently. I was piping this through a couple different things to handle the errors, and I was handling the errors correctly. But he was like, wait, you could just do effect.match cause, and it'll do the same thing, but it'll be less verbose and it'll feel nicer. And it's just like little things like that, just knowing all of the different right ways to do things. It's hard to figure out. It's hard to wrap your head around all of the different things that you could do with this library. I wish I had a really good answer here for like what you should do. Like if I could just tell you flat out, like, yes, you need to go learn Effect, or no, don't bother with it. Because the actual answer is, if you care enough, it is absolutely worth it. I am fully Effect pilled and I fully see the vision of what this will actually be, but also I wouldn't question anyone who didn't want to go deal with this. This is a lot. I had to do a lot of work and a lot of thinking and grinding to actually get all of this stuff working. I'm glad I did. It's going to make all my software way better. I think that the things that will come out of me using Effect are going to be really, really good. My programs are going to get better as a result of this, not worse. It makes TypeScript a better language. I'm very much in the camp at this point where I will fully admit any of the faults of Effect, and I fully understand anyone who doesn't want to go down that road. And to be honest though, if you made it this far in a video like this, you probably should go learn Effect. Like if you're watching this stuff in your free time and you care this much, it's worth going into this. It's going to make your stuff better. You should go try it.